Welcome to Chapter 7, Vitamins. If we look at vitamins are 1. Organic, they contain carbon; 2. Micronutrients, they're essential in small amounts; 3. Essential, which means they're needed from the diet; 4. Not energy yielding, which means they don't provide any calories. So we've already been through all the nutrients that provide calories. Vitamins are not those nutrients. And then there are two classifications of vitamins. They can either be water soluble or fat soluble. So here's a little overview of the vitamins. As you can see, there are two classes of water-soluble vitamins, including B and C, and then 4 classes of fat-soluble vitamins, including A, D, E, and K. Under B vitamins, we have 8 B vitamins. You'll notice that they go from 1 through 12 with a bunch missing in the middle. And that's because originally when B vitamins were discovered, thiamine was discovered first. They thought it was just a single vitamin because they all do very similar things. Then they identified 12 different vitamins, but then realized that some weren't essential. So these are the 8 B vitamins that we consider essential in our diet. Choline is sometimes put under B vitamins as well. It's not an essential nutrient, but sometimes is enhanced in different products and things as, it can be beneficial for health still, even though it's not essential. We do make some choline in our body. So here's a little vitamin primer today. Almost all foods contain some vitamins, and the amount of a vitamin in a food depends on the amount that's naturally present in the food, what's added to it, how the food's processed, prepared, and how it's stored. Because vitamins are organic molecules, they do tend to be destroyed by things like heat and light, in cooking, things like that. They might drip out into the water if you're boiling something, and we'll talk about that in a little bit. So this is just depicting where vitamins are found throughout the food pyramid. As you can see over here, grains and protein actually have many similar vitamins in them. So a lot of our whole grains, at least, and our proteins have very similar vitamins. Remember, some grains, or almost all grains in the US, have thiamine, riboflavin, and niacin added back to them as well. But, these might still be a little bit low if that grain is refined and not whole, the pantothenic acid, B6, folate, and vitamin E. Fortification. So some of you had questions on the difference between enrichment and fortification from chapter 2. Fortification means adding nutrients to foods. Enrichment is kind of a class underneath fortification, which means adding back something that was depleted during processing. And fortification typically refers to what's added as added value, so added more, all right? It's government mandated and voluntary. There are two different types of fortification. So in our society, we have folic acid, B12 mandated fortifications. We have thiamine, riboflavin, niacin, iron mandated enrichment, iodines mandated as enrichment, and salt. All the others I just mentioned are in grains. It can prevent deficiencies leading to diseases, but could also cause toxicity if consumed too much. So some of the designer foods that we talk about can actually cause toxicity symptoms. So this is just an example, the fortification of folate in flour, or of niacin in flour. I'll talk about folate in a little bit. This is of niacin in flour. So we see when voluntary enrichment started, the number of deaths from pellagra started decreasing. Now we have mandatory enrichment, and you can see that the number of deaths from niacin deficiency or pellagra have pretty much gotten down to none. A similar thing, I slipped and said folate before. Folic acid fortification in bread has also led to decreased deficiency symptoms, including pregnant women having babies with spina bifida, which we'll talk about in a little bit. Because they're organic, as I mentioned, which means they contain carbon, they're not like minerals that are as small as elements, vitamins can be destroyed and no longer perform their duty. So they could be damaged by exposure to light or oxygen, they could be washed away during preparation, destroyed by cooking. So vitamins really need to be handled with care during storage and cooking in order to actually get in all those vitamins that say that they're in different foods. So here are some tips for preserving the vitamins in your food. Storage. Store the food away from heat and light. Eat it soon after purchasing. Or freeze it. Freezing it can help to maintain the vitamin value in foods too. So something like frozen vegetables that are flash frozen on the field can be really good for that. Cut the fruits and veggies as close as possible to the time when they'll be cooked or served. Don't soak the vegetables. Cook the veggies with as little water as possible by microwaving, pressure cooking, roasting, grilling, stir frying, or baking rather than boiling them. If foods are cooked in water, use that cooking oil to make soups and sauces so then you can save some of the nutrients. Maybe you like boiled broccoli better than, I don't know, sauteed broccoli. That's fine, but just use that broccoli water for something else. Don't waste it. Also, don't rinse rice before cooking. The water-soluble vitamins like thiamine, niacin, and riboflavin are actually sprinkled on the top of enriched rice, and so you don't want to wash away all those enriched vitamins in that rice. So bioavailability, that means how much you absorb from how much you consume. So if something has 40% bioavailability, it means that only 40% of the nutrient actually is absorbed and can be used by the body versus what is consumed. Fat-soluble vitamins need fat to be absorbed, so the absorption of fat-soluble vitamins depends on fat consumption. Bioavailability in general depends on lots of different factors. One, the efficiency of digestion, time of transit through the GI tract, previous nutrient intake and nutrition status, other foods that you consume at the same time, method of preparation, and the source of the nutrient. So depending on whether the nutrient's synthetic, fortified, or naturally occurring, different absorption values will happen. And there's not one that's better than the other. Each nutrient is a little bit different in terms of the synthetic, fortified, or naturally occurring that is absorbed the best. Provitamins. So some vitamins are available from foods in inactive forms, and those are called precursors or provitamins. Once they're inside the body, the provitamin is converted to the active form of the vitamin. One example of this would be beta-carotene. It's a provitamin of vitamin A. So beta-carotene turns into retinol when it gets into the body and is much less toxic than consuming too much of the retinol itself. So this is a picture just showing the difference between fat-soluble and water-soluble vitamin absorption. So you can see water-soluble vitamins are absorbed much like carbs and protein are into the villi and then enter into the venule and then the vein and head to the portal vein, whereas fats are absorbed with lipids. They're incorporated into the chylomicron in the mucosal cell, and then they're sent through the lymph vessel, just like those lipids are, and they're transported by lipoproteins. So when we look at vitamin functions, we can think of some different functions that include things like energy, immune function, blood health, and bone health. Vitamins have two principal functions in the body. First function is as coenzymes. These are organic non-protein substances that bind to enzymes to promote their activity. Antioxidants are substances that decrease the adverse effects of reactive molecules on normal physiological function. So when we think about antioxidants, antioxidants protect against things that age us, things that cause cancer, things that cause heart disease. Coenzymes allow enzymes to activate, and so they are usually involved in energy metabolism and blood health. And here's an example of how coenzymes work. Now that little yellow chemical group that you see, that would be a cofactor, and that cofactor is typically a mineral. So typically a mineral or a chemical group binds to a vitamin, that whole functional coenzyme binds to an incomplete enzyme that activates the enzyme, which then causes a reaction to happen. There's lots of these going on in the citric acid cycle or Krebs cycle, an electron transport chain, and that's where most of those B vitamins that we talk about are involved. Free radicals and antioxidants. So as you can see here, free radicals are what we typically associate with diseases like atherosclerosis. We talked about oxidized LDL, free radicals attacking LDL, or cancer or aging. Free radicals can damage the DNA and other molecules, and things like vitamin C, vitamin A, vitamin E, as well as some of the trace minerals that we'll talk about in Chapter 8, help to neutralize these free radicals, preventing them from damaging DNA, and thus, skincare people would love to claim that they reverse the aging process, right? And then we also can see that they can have a lot of benefits in anti-cancer as well as anti-heart disease. Meeting vitamin needs. So you'll see that the DRIs for vitamins include some RDAs, some AIs when there's not enough information to establish the RDA, and most have ULs. Some of those B vitamins don't have a UL, however, because they're just urinated out when you consume too much of them. So water-soluble vitamins are much much less toxic than the fat-soluble vitamins are. And vitamins A and C are required on the current food label as percent daily value. We think that we're probably going to see vitamin D instead on the percent daily value with our new food label. So if you determine the exact amount of a vitamin in a food, you have to look up the daily value that's in Appendix 1 in your book and multiply it the percent daily value on the label. You might see a problem like this on your test bank questions, so just make sure you're able to calculate those values, and you might want to just bookmark Appendix 1 for that exam. So next time we're going to be talking about the water-soluble vitamins, which include those 8 B vitamins and vitamin C. This was an intro to the vitamin functions and water-soluble and fat-soluble vitamin digestion and absorption. See you next time for the water-soluble vitamins.